Okay, so in this particular video, set 1 SWYK 2, we are going to take a graph and change it back to the vertex form equation. So I'm looking at the picture. I can easily identify what the vertex is, 1, 5. Now, question is, what's the A value, right? Because we know that we're going to fill in, you got the 1 and the 5, right? So you know that you're going to have a 1 there and a +5 on the outside. Always looks backwards on the inside, looks exactly like what you think on the outside, that kind of sort of thing. Big question is what goes out here. Now, two different ways to handle this. If you've got a picture and the numbers are nice, it's easiest to just do this, in my opinion. Go 1 unit to the right and then count either up or down until you hit the graph. Now, obviously this only works if you've got nice numbers, and it looks like we do, right? Because all we have to do is go up 1 unit, so we know that the A value is a +1 in this case. Well, let's say they randomly gave me a point. Let's say they gave me this point over here. What is that? 3, 9. So let's say they randomly gave me that point 3, 9. It probably would be easiest if we did algebra on that kind of thing. Now you and I know that. So we're going to take the point 3, 9 and we're going to plug it in. We don't know what the A value is, but we do know that the X is 3 and the Y is 9. And we can go through this process. I would suggest to you that you do something for me. Move the 5 to the other side. Make that the very first thing you do. Trust me, if you do this, you are not going to make a mistake. Okay? At least I don't think you will. My face is in the way. Okay, so now what? We're going to, let's see, 3 minus 1 is 2, and 2 squared is 4. My cat is, no, I can't play right now. Okay? Ouch! Ooh, sorry. Claws in the knee. And so then divide by 4, and we get exactly what we thought, A value of 1. Was that a lot of extra work that I didn't need? Sure. But, and if I have a nice graph, use the graph. The 1A method, the just going to the right one and counting up or down until you hit the graph, usually takes care of it pretty quickly. And, oops, I didn't even mark that. Do I need to fill anything in here? No. If you leave it blank, Math Excel knows that it's a 1. If you put a 1 in there, Math Excel should not count it wrong. If it does, call your lawyer. Or just email me and let me know, because that is not wrong. Okay, so next question, same type of thing. You're looking at it, and you can see that the vertex is at 2, 7, and 1 unit to the right, and this time 5 units down hit the actual line. So we all know what's going to be in here. We all know that you got a -5 out there, X minus 2 and a +7. We know how to put in our vertex. We know how to put in the A value. If you didn't know that, obviously you could go through the process that we did a few minutes ago. But, take a point like 0, -13, plug it in, -13 equals A times 0 minus 2 quantity squared plus 7. As I suggested to you before, move the 7 to the other side. You will thank me for doing that, right? So there's a -20 equals. What is this thing right here? That would be 4A, and then you could divide by 4 on both sides and get an A value of -5. Still get the same result. Okay, moving. Oh, domain and range. I want to talk to you about domain and range. That's where you're talking about possible X's and possible Y's. We've talked about this before. Just want to, remind you. If you're pushing all the points onto the x-axis forever and ever and ever and ever and ever, this thing gets wider and wider and wider. Even though it looks like it goes down forever, it also gets wider and wider and wider and wider forever. Now, that would mean that the domain would reach all the way out to -infinity to +infinity. And so we want to say that, and I didn't leave myself enough room. And to do that, we're going to use the -infinity to infinity symbols. That's the equivalent of all real numbers, okay? But you're going to most likely see negative infinity to infinity. Okay, well, what about the good old range? Well, that's when you push the points over to the y-axis. Just kind of imagine crushing the whole graph onto the y-axis forever and ever and ever. It's going to start up here and it's going to go down forever and ever and ever. So we know that on our graph, negative infinity is down here, and it looks like it's going to stop at 7. Sometimes I try to get kids to take a graph and rotate it 90 degrees in the clockwise direction. Because if you did rotate it 90 degrees in the clockwise direction and kind of look at it, you'd have something that looked like this, okay? And you would see that 7 is over here, and you would have negative infinity that way. You know, I'm really physically talking about turning the graph just to look at it in a different perspective. And because most kids, when they turn the graph, they realize, oh, that domain goes from negative infinity to 7. Remember, the bracket has to be included because you are including 7. Okay, let's see if there's anything else I absolutely need to teach you on the next example, and if so, I need to pause. In this example, you can see that we have a vertex at 7, negative 30. Now, I didn't draw a beautiful picture. All I wanted to know is basic stuff, like what's the vertex? And I wanted to know, hey, does it open up or down? Obviously down. Okay, so I drew a basic looking shape. That's it. We know the vertex. We know the axis of symmetry, right? X equals 7. Remember how those two match. Now, we're going to talk about maximum value or minimum value. These are both, these terms, maximum and minimum, refer to y values. Okay, so you need to know that. They refer to y values. And yes, we have a maximum at negative 30. Keep that in mind. It's a maximum because you can see that there is no lowest y value. This thing goes down forever and ever and ever. There's no way to have a minimum on this particular graph. Now, if it had opened it the other direction, if something opens the other direction, of course it's got a minimum and no maximum. Now, what's the domain and range of this? Well, as we talked about before, you push all those points up on the x-axis, your domain. Hey, guess what? When you're talking about up opening and down opening parabolas, it's always all reals or negative infinity to infinity for the domain. Okay, little secret there for you. If we start talking about left and right opening ones, not so much. Okay, how about the range? Well, from that picture, you know that we're going negative 30 on down. So obviously, we want all values that are less than or equal to negative 30. Another way to say this would be negative infinity to negative 30 and stopping with that one right there. Those two things, you need to get used to both the interval notation and the inequality notation and kind of be able to go back and forth between them. Okay, talk to you later. Bye.